Well, in the previous videos, we saw how to use Ohm's law to analyze a circuit with either resistors hooked in series or resistors hooked in parallel. And now we would like to move ahead to circuits with possibly a combination of both series and parallel resistors. And just as before, we will see that any series parallel combination can be reduced to a single equivalent resistance. So, for example, we have in this diagram a resistor R1, 75 ohms, is hooked in series with a parallel combination. R2 and R3 are hooked in parallel, and we have 220 ohms for R2 and 150 ohms for R3, and we would like to get the equivalent resistance for this network. Okay, so the first thing to do with a problem like this is to find the equivalent resistance for this parallel combination. And then once we have that equivalent resistance for the parallel combination, we're going to add it to the first resistor. Okay, so the solution is right here in the notes. So let's just go ahead through the notes. Okay, we first find the conductances. G2 is 1 over R2, or about 0.00455. G3, 1 over R3, or about 0.00667. So we get the total conductance from the parallel combination, and we get 0.0112 Siemens. So this means that the parallel combination is equivalent to a resistance which I'll call Rx, which is the reciprocal of the total conductance, and that will give us a effective resistance of the parallel combination of 89 ohms. Okay, so then finally, what we have in effect is our original resistor R1, which I remind you was 75 ohms, in series with that equivalent resistance that we just calculated of 89 ohms. Since they're in series, we can just add those resistances and get the equivalent resistance for the original problem, 164 ohms.